In this lesson, we'll begin by reviewing the BVS Smart Camera interface to get you more associated with what it contains, and then we'll move forward into actually working with and creating a simple inspection configuration. Before we begin the process of building an actual application, again, we will review the cockpit interface to give you a basic outline of how the interface appears and where the features are located. We'll move forward into reviewing what the monitoring function menu is. Then we'll move forward into the configuration menu where you will actually build your application. And finally, we'll review the statistics tab in the application so you get a better understanding of what's available and how this can be used to your benefit when measuring the results of your application. So let's begin by reviewing the BVS Smart Camera interface. Begin by typing in the address on the label on the top of the camera, as shown in the top of the address line here. Once you get online with the camera, we'll begin the process of reviewing what each part of the interface actually means. Once the BVS Smart Camera interface has come up, we'll review the different aspects of this interface. You'll start by noticing there's a drop-down arrow on the top left side that gives you access to the monitoring, configuration, and statistics window. You'll also notice a run button, a stop button, and a load button. We'll review the purposes of those in a moment. On the interface, on the far left side, scrolling downward, this will be used to either monitor the inspections that are taking place or the individual features of the other two submenus. The center of the screen will be used to display the image from the camera. The bottom of the screen is where you will see the results posted from any of the given measurements you select to monitor. On the far side, on the right side, you will notice that this is an online help menu that will scroll through as you click on and detect the individual things within the menu system. Above that, you will notice four small icons, starting with the password icon. If the password has been set for any of the given levels of the camera, this is the icon you will click on to log on to them. Followed by the camera icon next to that. The camera icon is used to select the different systems that you may have logged on to the same network of BVS smart cameras. In this case, I only have one camera connected, but had I had multiple cameras connected, you will be able to select and switch between each of those cameras using this interface. The icon located next to that is the gear icon, which we covered as the system setting menu. And finally, on the far right side, the question mark icon will turn on and off the help menu to the far right as needed. Below these icons, you will also notice in the same help window, there is an ability to select a drop-down that will open up the software or hardware manual for you, as well as give you information about the licensing. Just to the left of that, you will notice an arrow that collapses the help window for you, as well as clicking on the question mark icon to open and close the window. So let's begin to look at how we would go about building an application with the smart camera. If you notice, you will come by default in the monitoring tab on the far left side whenever starting the program. Again, this drop-down menu gives you access to the monitoring, configuration, and statistics part of the camera and is the core of the three pieces used to build an application. Within the monitoring window, you have the run and stop features for the camera, as well as the load. Let's look at the load feature. To start a new application, when you click on load, it will open the Manage Inspection Programs window. Here you can either load a previously designed program that you had created, or you can load a new program that will start with a new fresh set of configurations. In this case, we'll start with the new one by clicking on the New button. Then simply close the window. You'll also notice that it does show you your used disk space for your PC at the bottom. Now let's look at setting up a basic application. Select the drop-down menu under Monitor, selecting Configuration. In this window, you will notice now that there are some basic tools that will appear on that left side menu for the drop-down of the configuration tools. You will also notice now that the result window is showing the result for the setup of the camera tool that's highlighted up at this top point. Now in the case of this application, we're going to start out with the camera setup tool and the get image tool, but we'll leave the read text tool for a later application. We'll simply click on this set of 3 dots on the right side of the tool, hit delete, and remove it from this menu. And instead we'll hit the insert new tools, and we're going to add to this the find object tool. As we will click back on this, as well as the check object tool. And then finally we'll add the send results tool. You will also notice that you will now start to see results from the individual tools that are active down towards the bottom right of the screen. Starting with the camera setup tool, there are 2 ways to go about running this tool. I find that the easiest way is to not move directly into the wizard right away, which is what this icon represents. It looks like a magic wand. Instead, to start with the wrench tool. Clicking on the wrench tool, you'll notice that the configuration parameters for this tool are going to be displayed for you on the left side of the menu. Starting with the active camera. At this choice, you have the ability to pull down multiple cameras that are active for being able to use this tool, or the ability to bring up images from files if you wish to use images that are captured on a file device. Use for inspection processing. You want to make sure that this is checked to make sure that if you don't want to use this tool for the inspection results, then you would uncheck this box. You have the ability to set the size of the image from full screen, which is currently based on the resolution of the camera, which is what you see here. You could adjust that down either in the X and the Y or the width and the height from the start position to their maximum positions. You also have the ability to adjust the exposure time, enable the flash, trigger your triggering mode, which can be set off of a level mode from a sensor, the edge detection from a sensor, or continuous. For the sake of what we're doing here today, we'll run this in continuous mode, as I'm not using a sensor to trigger the camera. You have the ability to set the frame rate when running in continuous mode. The default for this is 20 frames per second. My recommendation is for configuration that's more than adequate. You probably don't need to run it much faster than that. Then you have a choice finally to use calibration or not. Calibration would be very useful with the wizard tool, which I'll show in a moment. And then you have a choice to either do nothing, which would be to not use calibration. You can use calibration on the results of the image, or you can use calibration on the image itself. It is also important to remember that if you're going to be doing anything with mirroring and rotation, you will want to make sure that you use the image selection for calibration at this point. Once you've made these settings to the camera, you can either put it in loop mode, in which case it will begin to acquire images right away, or you can put it in run once, which would be every time you trigger it, you have the ability to trigger through it. You can also use step mode, but not at this stage. In this case, you can see by the image that I'm acquiring of the calibration grid, which I'll explain in a moment, that it is overexposed. Now, I do not have direct control over the iris of the camera, in this case of the lens that I'm using, so I have the ability to adjust it here. Now, I know from previous setup that I can use it at 0.3 and use that for my exposure rate. Now, one thing you want to be very cautious of, at this stage, it's easier to set up your calibration grid manually at this stage, because you'll notice that within certain areas, there are dots in the center of the white circles. These dots are actually going to be located and used for calibration purposes. So it's easier to configure the image, the exposure, and make sure that your focus is correct at this stage before moving on to the calibration to make calibration much easier. Once this is done, go to the back button on your camera setup tool, then choose the wand for calibration purposes. It'll ask you to go forward and move forward with the calibration process by clicking on the right arrow. You have a choice of using the camera with or without calibration. In this particular example, I'm going to go ahead and use calibration. You have a choice of selecting 3 different grids. These grids, based in millimeters, will print on your printer if you need one by going over here to the help section and printing them off of this side guide. Just by clicking on one of those 2 sections, you'll open up a PDF. You will want to make sure when you print that PDF, you do not use the fit to page size. You will want to make sure that you actually use the actual size of the image when printing that image. Assuming that you have now printed that calibration guide and put that onto your camera, set the exposure and set the focal length on it, you can then select the guide over here that you used for calibration on the left side. In this case, it was an 80 by 60 millimeter. Next, you'll want to capture the image that you've set up that the camera will now use to automatically calibrate. Once the calibration is through, you'll be able to use the measurements that are taken with the actual values representing it. You'll also notice in the image here, there are calibration lines there exhibiting the fact that the calibration had been made. When finished, hit the Finish wizard. This will take you back to the parameter settings for that tool, and to go back to your main menu, you simply click on the left arrow again to bring you back to the main menu. Next, we will check and make sure that our Get Image tool is configured. You do have the ability to acquire multiple Get Image tools at this point. You can simply duplicate them or select one from the Insert a New Tool process. In this case, we're going to click on the tool wrench to be able to set up the tool parameters. We'll go to make sure the run condition is true, and we will use this tool for inspection purposes by making sure this box is clicked on. Click on the left arrow to return back to the main menu. Now within this tool, of course, you have the ability to run once to acquire the image, or loop to require multiple images. If you press loop, you will find that the tool is processing successfully. You'll be able to see the execution duration in milliseconds for the tool. You'll be able to notice that the output image is checked, showing the size of the output image and that it is a monochrome image, as well as any trigger alarms, which right now are false. After going back to Setup Camera and establishing the image and making adjustments as necessary to your camera to be able to clearly see the object you want to measure, as you can see in this display I have now, you want to move forward to your Find Object tool. This tool will be critical to compensate for any movement or rotation of the object that you're trying to find. There is a wizard tool available for this tool, and in this case, the wizard is usually the best thing to start with. Click on the magic wand. It'll tell you that the next steps will be used to define the object and its position. The first thing you want to do is train the object. We'll go ahead and leave this default as Object 1, but you can go ahead and customize it as needed. You want to go ahead and capture a static background without the object in the image. Do this by simply removing the part from the image. Once the part's been removed, hit the Capture button. You want to reposition the image, or reposition the object in the image. In an area that best suits where that object will be located during the measurement. Now, if you're using this in an application where it's on a conveyor or a fixed means of holding the part, this part of the application will be much simpler. Just make sure you capture the image at a point where there is no object in the image, even if it's just the background conveyor. You will notice, by the way, that the image is in loop capture mode. Once you've got the image back in the area, hit the Capture tool. Once that happens, you'll have a mask that shows where it sees the outline of the image. If this mask is too large and you are unable to use this mask, or it's all the information it's defining for the purposes of this measurement, you have the ability to redefine or delete the mask and create a new mask. One thing to note, the larger and more detail you use in the mask, the more accurate it will be, but it will also take longer in execution time. So you want to be cautious about how much information you're using for this tool and only use what's necessary. To use this tool, you start by deleting the mask if you need to use a new one. Go up to the masking tools, select the type of line or space or area you wish to use to define the mask. In this case, I'll use a square, but you have the ability to use an oval, a squiggly line set, or basically a defined line set, a single line set, or back to the square. In this case, I'm going to go ahead and establish Balef as the area I wish to use for location. Once that's complete, I hit the next arrow button to move over to the next step. It is now capturing that image, and as you can see, it's defined the Balef as its locating image. Now, one thing to note here is you'll notice that I have a small line located right here at the top of that line. If that seems to be an interference, you can go back and redefine the mask, or you can leave it there based on whatever results and sensitivity you're looking for. In this case, I'll leave this here. It will add to my sensitivity and make it more sensitive to the rotation and movement of the object. You can also move forward and define another object type if you wish. And this is, at this point, it can be handy to define two object types if trying to measure rotation with a high degree of accuracy. In this case, I'll hit the Finish Wizard. This will take me to all of my setup tools that I've used for the object, for the parameters of setting the object. You'll notice I now have a successful object, and the number of objects found is 1. You'll also see a search area reference point down here in your results. That search area reference point is going to be where it sees the object now, which in this case is at the original position of 0 degrees. Your position direction in X and Y are also defined according to your calibration template, and that is indicated by the center of gravity, which is where the green dot will be seen in the image. You can see that there is basically no displacement nor any rotation at this point, and my degree of match is very, very high at 99%. This is where you can make fine-tuning on the success of the image. You will want to do so depending on the amount of variability you have in the image. For example, if there is some variability in light and positioning that may cause some inaccuracy, you might want to change the match and bring it down to a smaller value. For example, we'll make it 75%. We will always be looking for one object, but if you have multiple objects, you can put it in at this point to search for multiple objects. I also do not expect this object to rotate more than 30 degrees. So I will put this or change these values to show this. For the positive number, you do not need to add the plus sign. Just simply type in the number. Once this has been done, I'm giving it plus or minus 30 degrees of rotation. To check this, I can go back and hit Run once. I can also change the positioning of my object, hit trigger again, run once again, and make sure that it is measuring the object accordingly. You will notice it is following the object in rotation and reporting that object's rotation down here in my results. I'm still running a very high degree of match, but you'll notice I'm at negative 23 degrees. You'll also notice that it is detecting displacement in millimeters from the original centerline point, as well as the position in the X and the Y direction here. Now you've established the object and your ability to track that object. If you want, you can also compare that to the original output image, and you'll notice that the output image has been corrected for the rotation to center it. This will be critical as we start to add tools because you will want to use the output image from the Find Object tool as the tool you use as the reference image. By doing so, you will always have the same reference positioning for your object that your measurement tool can use to find the feature you're looking for, the measurement you're trying to make. So you'll always want to make sure you use the output image of the Find Object tool, as opposed to the input image, which is the raw image used for searching. As the final step in this lesson, we'll move forward to the simplest measurement called Check Object. We're looking at the output image of the Find Object tool. Next, we'll click on the Check Object tool. The easiest way to use this tool is with the wizard wand again. We'll want to identify changes in the object with this tool, and the best way to do this is through the training in the wizard. We want to make sure that we have at least several different training images to make sure we can learn what this is. You'll notice that the input image is actually based on the output image of our Find Object tool. Starting with this first object, we'll tell it to learn this object. Now in this case, I'm using the same object, but I will simply rotate this object, repositioning it as well, to learn it as another good object. And I will do this at least 3 times, preferably 5, to grab the most stablest object you can. If you have multiple objects to work with, you will want to make sure you cycle through each one to identify each one as a good image. As you can see, it's in loop mode, and it's just simply adapting to every change I make in the image. Now that I've trained that, it's going to ask me to train for bad parts. I'm going to mimic bad parts at this point, just so that you have the ability to see what it will do. Here is an example of one of the bad parts that I will teach it. Again, another example of a bad part. And finally, one last example of a bad part. Again, training as many bad parts as possible will help improve the accuracy of this tool. Once you've taught it the good and bad parts, you're ready to move forward to set up the actual inspection. Keep in mind again that the more good and bad parts you train it, the greater your accuracy will be. But be aware of the fact that you are working off of the Find Object tool. If you obscure the area you're searching for with your Find Object tool, you will not be able to see the part at this stage in the output image, as I'll demonstrate here. Because I covered the Balluff logo, the Find Object tool was unable to locate the object, so be aware of that when teaching good and bad parts. Click the right arrow to move forward. The mask that will be set up will be the maximum area mask. If you need to make a change to that mask, simply hit Delete, go up to your masking tools. In this case, I'll choose a circular tool. Try to center it as best you can on the object. Draw it out to establish the entire object area as a mask. But again, do not include more information than you need, as it will increase the processing time of the tool. You can also want to make sure you don't set too little information in order to make sure that you get the most accuracy from this tool. Once the mask has been defined, click on the right arrow. It will process the mask and define what should be a good part for you. Once the tool is finished, simply hit the Finish Wizard button. This will be the object you've taught it. You want to make sure, looking at these parameters, that you're looking at the output image from the Find Object tool. In this case, you have 2 different settings on here. You can either use edge-based or intensity-based. This is an example of the intensity-based. This would be an example of the edge-based. We're going to use intensity-based for this example. We have the ability to set the maximum defect size in pixels, as well as the critical defect size in pixels, and the sensitivity of the tool. Now this was all preset by the wizard tool when we first started. Now that I've finished configuring all of my tools, I want to go and run this application just to see how it's operating. This represents essentially a finished simple application. There are no outputs set at this time. We'll do that in a later lesson. To check on the operation, we'll go back to the Monitoring tab. In the Monitoring tab, we can start by hitting the Run button, which will begin to run continuously as a trigger based on our settings in the Find Image category. Now, as you can see, it is seeing that image and seeing that part. If I make changes to the part, you will notice the changes that will occur in the image. It is following the part, but you'll notice the failed images occurred when I distorted the object based on my check image tool. You can see this distortion taking place with my fingerprint and distortion of the light over the object. Because I told it to check the entire object, that's why you're seeing even those small changes that are taking place in the image. So at this point, I've created a very simple application just to check the object for integrity, as well as being able to track the object using the Find Object tool. Finally, let's look at the statistics that come from this application we've just set up. Click on the Statistics tab. In the Statistics tab, you will notice that there is a bar graph that will show you the application's results for a given tool, which is indicated here on the left sidebar, as well as the inspection number down in the bottom bar. You will also notice that there is a small donut chart that shows you the yield percentage of OK to no good images. We can refresh this list by hitting the reset, by hitting a refresh button, or we can reset all the values that are from the deletion or from the statistics results. Going back up to Monitor, we can begin to run our application. And while running the application, we can create some defects in this image. And then after creating these defects, we can stop the application, go down to Statistics, and look and see what our values are for the statistics we're showing at this point. You will have the ability to look at several different ways of seeing the graph. In this case, it's set to 100, but you can simply open it up to see many more samples that were taken at the rate. We will explore statistics in more detail once we get into each of the individual tools that we'll be creating and adding to this application as we move forward. This ends the lesson for the basic inspection and configuration. In the next lessons, we'll begin to explore the individual tools and what they are capable of doing, at least from a basic configuration standpoint. These tools can be used in very elaborate ways going forward, but these are intended just to get you started.